and welcome to Americans Learn. My name is Lauren, and today I'm going to be watching a video by Emporium. I think I've watched a video from Emporium before. Anyway, it's called Yellowstone Won't Explode and End Civilization. Sorry, which is a bummer. That was a thing that I had read about, like the caldera under Yellowstone it's meant to explode, and it hasn't. And the longer that it takes, the more dangerous it gets. So that is that is something I'd heard, that like we're overdue for a Yellowstone explosion. But Emporium is saying that it's gonna be fine. So number one, huge bummer. Number two, let's find out why.
All right, new video, time to spin the content wheel. Yes, Volcano chat. Yellowstone won't explode and end civilization. Wait, what? Yes, it will. That's what everyone says about Yellowstone.
It is
We're
what
all sitting on a civilization-ending ticking time bomb. Yellowstone is overdue for a super eruption. It gets thousands of earthquakes a year.
That's what I've
filled
heard.
up with magma. It's only a matter of time before it goes. And when Yellowstone goes,
We all go
it'll
with
be
it.
Armageddon.
The Yellowstone accelerationist. Moop staring into space, that scene from 2012 playing. With explosions and stuff.
Yeah, I know that's what everyone says, but it's not true. Now put on your pajamas and make yourself a sleepy tea, because it's time to get into our debunk beds.
I like it! Our debunk beds! That's fun! I don't want tea. Especially sleepy tea. Maybe a drink, maybe wine. And is wine my sleepy tea? A little bit, yeah.
Your ex-girlfriend wasn't lying when she said you weren't. Just get in the bed.
That was fun! Shut up! I have a feeling some copyright issues are going to happen for me tonight. Bummer. Whee!
But Yellowstone is a ticking time bomb. It could erupt tomorrow. I mean, it could, but it's not likely. Yellowstone is one of the most well-watched volcanoes on the planet. I'm talking GPS, LiDAR, seismic stations, field monitoring, ankle bracelets. If Yellowstone were about to explode, we'd be seeing a lot more activity on it. I'm talking magnitude-5 earthquake swarms, meters of uplift a year, explosions from geothermal reservoirs, curfew
Not
breaking.
just Old
We
Faithful.
don't really see any of that. And since these precursors to volcanic eruptions typically take days to weeks before an actual eruption, it's safe to assume that one's not on the horizon. And we'll get plenty of warning if that ever changes. I mean, don't you think the army of volcanologists who dedicate their lives to monitoring the Yellowstone caldera system would have alerted everyone to an existential crisis if it were just around the corner?
I mean, maybe not. You know, people do a lot of stuff in the interest of not causing panic. Lots of lies have happened because they didn't want to cause panic.
But isn't Yellowstone...
I mean, think about what happened with the Y2K thing. Like, everyone was freaking out. Like, so many people like were in total panic mode because they found out that the computers weren't like set to, like, they weren't set properly, or they had not set past 99. So it's like, I mean, yes, they had people working behind the scenes to make sure that things didn't go crazy wrong, but everyone was very worried, according to various YouTube videos I've watched, because I was not old enough to be paying attention to that kind of thing. I was like, okay, 2000, yay, millennium, new 1,000 years. I kind of understand what's going on, is kind of where I was at in the year 2000. I remember that they had an assembly at school. The only thing I remember about the assembly was the construction paper banner that they had made with the silver welcome new millennium written on it. Like those like bubble letters, like those happy birthday banners, but except for it was welcome new millennium. That's the only thing I remember.
Stone always uplifting? Isn't that a sign of magma accumulation and an impending explosive eruption? No. Yellowstone's moved a lot over its history. We can go all the way back to the end of the last glacial maximum, a funky way of saying ice age, and see these lake terraces along the northern part of Lake Yellowstone at Mary Bay. Right.
It's actually a lot less fun. Glacial maximum is less fun than saying ice age.
Ice age, and see these lake terraces along the northern part of Lake Yellowstone at Mary Bay. Right. Little
See, I like the Mary Berry joke.
bake-off joke for you there. These terraces at Mary Bay were formed by water erosion, and the fact that we see so many of these terraces suggests
Pelican
that
Creek.
Yellowstone Lake has risen and fallen historically. Since the lake is
Oh.
closed off from other large bodies of water, we know the lake levels are due to subsidence and uplift. We can date these terraces using archaeological evidence and tetrachronology, dating things by looking at my Australian ash deposits from the past eruptions, and determine that since the end of the last ice age, Yellowstone has
It's a
subsided
great
by
Australian accent. Got a fantastic Australian accent, you know it.
from the past eruptions, and
I'm
determine
so
that
bad
since
at
the
them.
end of the last ice age, Yellowstone has subsided by 100 foot, or 30 meters in sensible units. Yellowstone still has these patterns of uplift and subsidence. Remember when I said Yellowstone is one of the most well-watched volcanoes on Earth? Of course you do, it was less than a minute ago.
Yes.
A leveling survey done in 1923 and repeated in the mid-1970s suggests that ground at Yellowstone has uplifted by a maximum of 72 centimeters in the last 50 years between surveys, a rate of about 1.4 centimeters a year. Based on GPS data, we can see that the northernmost point of the caldera had marked uplift between 2004 and 2009, and then it gradually subsided, and then another bit of uplift between 2014 and 2015.
I don't know if that's a
and since
big
then,
deal.
The northern point of the caldera has been subsiding.
I don't know if it's a big deal. They set how many centimeters up and down. I'm not sure. Like, is that a lot or is that not a lot? Is that not as much to be worried about?
We can see the same thing around Old Faithful, uplift and subsidence, up and down, about 1 or 2 centimeters a year, or
That's
an
it?
inch in American
Okay.
units. This is quite normal in Yellowstone. The amount it's currently moving is consistent with historical norms. And an inch a year is still quite impressive. That's not what your mom thinks. Oh!
You did it. You got him. Got him. Burn.
The movement is impressive, but the inch or so a year Yellowstone moves pales in comparison to campy fleg.
It's pronounced
Campi Flegrei.
Oh, Google
Campy
Translate, I
flegrei.
love you.
I think we should just be friends.
I meant it more in the Platonic.
Up and AWA.
Leveling surveys started at
Campi Flegrei.
in 1905 and were repeated frequently to assess how the ground moved, since deformation was a well-known phenomenon in the region. Between 1905 and 1950, the caldera subsided by over a meter. Then
Wow.
several episodes of uplift occurred. The largest were between 1969 and 1972 and 1982 to 1984,
That's a
but the
lot.
ground rose by
That's huge.
1.75 meters during each episode. When you plot the vertical deformation
Campi Flegrei.
at the same scale
Campi
as that Long Valley
Flegrei.
in Yellowstone, the lines for the calderas in USA look almost flat. But wait, there's more! Near the center of the caldera is a 2,000-year-old Roman ruin that has 3 columns, all of which have evidence of mollusk borings several meters above their bases. The columns
Oh, so
are
there
above
was
sea level
water.
now, and they were built above sea level. Obviously, the Romans weren't sea people. But between the time they were
Were they?
built and now, the ground subsided below sea level by several meters and then rose out of the sea once again.
Oh,
It
that's
was the
so
study of
cool.
this site in the 1820s that convinced geologists that the ground at volcanoes could move up and down by dramatic amounts due to
Oh.
subsurface magmatic activity.
That's
right,
really
so
cool.
Yellowstone's uplift and subsidence is caused by magma then? No. Let's cut this hot button half
No.
and look inside. This is a tomograph.
But from what I like, the Yellowstone I thought was a water volcano more than a magma. Isn't that a thing? Why do I even ask? Why do I ask questions about science? I don't know anything.
P-wave model of the Yellowstone caldera.
Oh, and that's not me calling myself an idiot, Pterodactylus. I did say that I was going to stop doing that. I failed to remember that that was my New Year's resolution. Thank you for reminding me that me saying I don't know anything about the science is not me calling myself an idiot. It's just me saying I have a limited knowledge base on this particular kind of topic. Gotcha.
System. Think of it like a CAT scan, but for the Earth. Tomography uses earthquakes and measures bounce-back times and wave amplitudes to infer how the material inside the Earth changed the speed and energy of the seismic waves, and thus what the inside of the Earth is made of. In Yellowstone, you have 2 magma mush reservoirs. Now, there isn't time to get into what a mush is. Read this paper.
Oh,
The
bummer.
one at the
No,
top is
I won't.
located in the shallow crust, only 5 to 17 kilometers, or about 3 to 10 miles below the Earth's surface, and that provides the heat to fuel Yellowstone's hydrothermal systems of hot springs, mud spots, and geysers. The upper
Okay.
magma reservoir is
Geysers.
made of a rhyolite melt, a very viscous magma due to its high silica content, and a less dense kind of magma than other types. Below the rhyolite reservoir, about 20 to 50 kilometers down, is a basaltic reservoir made of a denser, runnier kind of magma. The
Okay.
formation of these 2 distinct magmatic components are either from the gradual cooling of this basaltic block, which created a rhyolite, which then separated out into the less dense rhyolite chamber, or melting of the country rock due to the heat provided by the basalt made the rhyolite chamber. And in the caldera system, we don't see any basaltic lavas. All the basalt lavas in the region surround the caldera, caldera, but within the caldera system, there's no basaltic lavas at all. This lack of
Okay.
basalt is actually pretty good evidence that the rhyolite chamber is still molten, and the two distinct chambers actually explains why we don't see basaltic eruptions in the caldera like in other hotspot volcanic systems like Hawaii, because the higher density basalt can't break through the lower density rhyolite. Sorry, I got distracted there. Volcanoes
Okay,
erupt
I
when
was
there's a
wondering, I was like trying to figure out like what does that have to do like with anything, and maybe where I got my like water thing, but okay, denser material can't get past the more liquid.
amount of available magma below the surface and a sufficient amount of pressure to force it to the surface. We know based on tomographic data that the rhyolite melt is only 5 to 15% molten,
that's
and that
not
the
very
basaltic
much.
melt below it is only 2%.
That's
molten.
even less.
So even though the rhyolite melt is partially molten, the Yellowstone caldera doesn't have enough magma in the system to cause a large eruption. The main magma bodies are too frozen. Magma typically doesn't erupt unless it has more than 50% melt. The amount Yellowstone is moving up and down suggests it's not magma accumulating.
What does the numbers at the top mean? The 7, the 14, the 3, like I don't know what those numbers at the top mean.
Driving these cycles of uplift and subsidence is more likely to be hydrothermal fluids like gases and
Hydrothermal.
water.
Ha!
But
See,
Yellowstone
water and
gets
gas,
A
that's
lot
what I
of
said.
earthquakes, aren't they signs of magma accumulation?
Not
So
always.
Yellowstone does get a lot of earthquakes, and about half of them occur in swarms along these bands. Last year, Yellowstone got over 2,000 earthquakes, but most of those were magnitude 2 or smaller.
Oh,
They're
so
not
you
really
barely
felt
feel
by
them.
anyone. And they're not driven by magma buildup either. We can actually figure out if an earthquake is caused by the movement of magma or subsurface water because each driver has unique characteristics.
Okay,
While
cool.
water can travel through very small pre-existing cracks or faults within the crust, magma requires a much thicker crack to allow the magma to push through without cooling
'Cause
and
it's
solidifying.
thicker, it
So
makes
water
sense.
earthquakes will migrate upwards and laterally across space and time. Because magma needs a thick crack to push through, we usually see surface deformation as well. You know, because the rocks are being pushed up. That
Okay.
typically doesn't happen with water. Also, earthquakes triggered by water will usually occur as fault slips on faults which the fluids are moving through. So the two sides of the crack hosting the fluid are still in contact with each other, but the fluid reduces the clamping forces and lubricates the fault enough to allow it to slip. In
Okay.
contrast, the walls of a crack hosting magma are generally not in direct contact with each other. They're separated by the magma itself. So
Right,
rather
because it would need the space to have like, because if it, it's heat still, so and if heat is what's kind of pushing it forward, the less heat, like less air getting into it to like let it breathe, essentially, the colder it gets, and then it freezes. Okay, I think I get it.
Rather than occurring by a slip between the walls of the crack, earthquakes will instead occur near the crack tip, the point ahead of the magma where the crack is starting to open, or off to the sides of the crack because the opening of the rock stresses the surrounding rocks. So if it's a water-driven fault slip, then the earthquakes will repeatedly occur on the same small sticky patches within already present faults, and the migration will be fast because it's not forcing the rock apart.
All right.
Let's have a look at the 2017 Maple Creek earthquake swarm. In June of 2017, an earthquake swarm began beneath the western edge of the Yellowstone National Park, and it lasted about 3 months.
Wow.
From a geological perspective, this swarm was really good for figuring out what's going on beneath the surface of Yellowstone because it produced thousands of earthquakes.
That's crazy.
This graph is plotting earthquakes from the Maple Creek swarm by time, depth, and location. A lot of the earthquakes are parallel and oriented along the east-northeast trend, but some earthquakes also occurred on faults with orientations that are nearly perpendicular to that trend. Over the 3 months of the swarm, you can see that the earthquakes migrated outwards from their initial activation area, both laterally and in depth. Sometimes this was a fast migration, and other times it was slow, and we didn't see large deformation of the surface at the same time as the earthquake swarm. The mix of colours at the same latitude and depth also suggests that the same faults are being reactivated. This kind of pattern isn't indicative of magma. They're likely being driven by the release of heated water in the deep crust. Almost all earthquakes at Yellowstone are brittle failure events caused when rocks break due to crustal stresses, usually from hot water interacting with the cooler, brittle surface rocks, stressed from the fact they go up and down more than your mom does. Oh, sorry, I'll stop
No,
those.
please don't. Keep going.
No, sorry.
He's reading 50 Shades of Grey. Anyway, hey, but I was right about the water thing. See, I do know some stuff.
I don't buy this. Yellowstone has a history of super eruptions. It's called a supervolcano for a reason.
'Cause
Just because
it's big.
quiet now doesn't mean it's not overdue for a civilization-ending eruption. Okay, well, first off, Yellowstone isn't a supervolcano. Yeah, Yellowstone
not?
is one of the largest caldera systems on the planet, but the term supervolcano isn't a widely used term, academically
bummer.
speaking. One of its first documented uses was in a review of a book by volcanologist Howell Williams in the mid-1940s called The Ancient Volcanoes of Oregon. Williams was challenging the idea that the three-sister volcanic system was a supersystem. He thought they were three separate volcanoes.
In 1924, he performed a field work around the Three Sisters and concluded that the three adjacent volcanoes and their foothills were once a part of a single giant volcano dubbed Mount Multnomah. This hypothesis was rejected by Howell Williams, who concluded that each batch, or each of the three sisters and their surrounding mountains, were unique and did not represent the remains of a single collapsed structure.
Volcanic systems. In the review of Williams' book, F.M. Byers Jr. refers to Mount Multnomah as a supervolcano, not Yellowstone, but he wasn't using supervolcano scientifically because it's not a scientific term. The term supervolcano only really caught on in popular culture when the BBC's Horizon program stuck the term onto Yellowstone and then some other documentaries ran with it. And it's a misleading term.
BBC, and then the Discovery Channel, of course it did.
Volcano, what do you think?
If a supervolcano were to erupt, would it take us back to the Ice Age? Wipe out half the global population? Or push humanity to the brink of extinction?
Yeah, remember when Discovery Channel did real documentaries? Because I don't. Supervolcano
I was gonna say not really.
System only produces super eruptions, but Yellowstone and other large volcanoes have lots of different eruption styles. Pacaya in Guatemala has the potential to produce a super colossal eruption in the next millennia, but when I climbed up it, it was just producing effusive lavas. Another volcano I climbed up in Guatemala, Santa Maria, has a history of colossal eruptions, but the massive dacitic Santiaguito dome attached to it has very regular eruptive patterns. Transitions from effusive to explosive activity and vice versa can be rapid, but all this says is volcanic systems are dynamic. Yellowstone's eruption isn't guaranteed.
Also cool that he's climbed a bunch of volcanoes. That's pretty sick if he did it for real and it's not just his character saying that. But anyway, you know, I'd like to climb a volcano.
To be a super eruption. Now, Yellowstone does have a history of super eruptions which are an 8 on the volcanic explosivity index. About 2.1 million years ago, an eruption that formed the Yellowstone Huckleberry Ridge Tuff produced 2,500 cubic kilometers of material with widespread continental ashfall. About 1.3 million years ago, at Henry's Fork, which formed the Yellowstone Mesa Falls Tuff, a super eruption generated 280 cubic kilometers of material. And 631,000 years ago, the eruption which formed Yellowstone Lava Creek generated 1,000 cubic kilometers of material. So Yellowstone has had super eruptions before? Yeah. So it's overdue for a super eruption. No. First off, the most common kind of eruptive activity in Yellowstone are lava flows, and even then they aren't that common. The last one was about 70,000 years ago. The most likely kind of hazardous eruption at Yellowstone, according to the US Geological Survey, is a hydrothermal eruption. Think of a big geyser going off.
Nice and cool, you know what I mean?
But second, volcanoes aren't overdue. That's not how volcanoes work. Some volcanoes have cyclical patterns of behavior, but the idea of the Yellowstone caldera system being overdue comes from looking at the time gaps between previous super eruptions. The idea is that since super eruptions were all separated by 600,000 years or so, and since the last one was 631,000 years ago, we're 31,000 years overdue.
That's way more overdue than I was thinking. See, like I said, I'd heard that we were overdue for like I said at the beginning. The only thing I knew about this when I clicked on the video was that everything I knew about it was wrong. Which was, again, super volcano overdue for an eruption. I was right about the water thing, though. I was like, it's a water eruption is more likely. So I was correct about the water. That piece of my information was still right.
And there's a few problems with that. First, this is based on 3 data points. It's not a solid assumption. Volcanic
systems we weren't
are
around for any of those times.
You can't use 3 numbers to get a meaningful statistic on this next eruption. And the intervals aren't even 600,000 years apart. 2.1 million minus 1.3 million equals 800,000. 1.3 million minus 631,000 is 669,000. 800,000 plus 669,000 is 1.469 million. Divide that by 2 means 734,500 years between eruptions, which means the average time between massive eruptions isn't even close to 600,000 years. So Yellowstone isn't overdue at all by those numbers. Most volcanic systems don't have multiple big eruptive events. When they do, the super eruptions aren't evenly spaced in time. And 3, just to complicate things, Yellowstone is a hotspot volcano. Most volcanoes form around zones of tectonic activity where the plates either move apart or get subducted under each other. The most prominent area of volcanic activity on Earth is the Pacific Ring of Fire. Hotspots, by contrast, are zones of melting that are relatively stationary on the Earth, where the volcano forms around a convecting mantle plume while the plate above it moves. This is how the island chain of Hawaii formed. The island arc is evidence of the Pacific plate moving relative to the hotspot which formed Hawaii.
Interesting.
The same principle applies to Yellowstone. The movement of the North American tectonic plate creates a chain of calderas. We can't see the calderas anymore because of erosion and because they get buried beneath younger basaltic lava flows and sediment.
That's cool, though.
The Snake River Plain, the flocation location of the last caldera system from this hotspot. But we can trace the hotspot's migration across the states from northern Nevada to Wyoming.
Oh, that's
if you
sick!
the eruption history across the hotspot's migration to include super eruptions from the past caldera systems, that makes 15 large calderas in 16.5 million years. That makes an average of 1.1 million years between big calderas. So we have even more headroom.
Yeah, a lot of
Let's
time.
go back to the magmatic system beneath Yellowstone caldera driving its eruptions. Remember when I said that was a sidetrack? I lied. Ha! The motion of the moving plate and hotspot creates this conveyor belt of caldera clusters. So we can look at the past caldera systems and compare those to the current petrology in Yellowstone to learn about the cycle of magma production and potential futures for Yellowstone. And there's good evidence to suggest that Yellowstone could be shutting down. This one will take some explaining. Water contains two elements, hydrogen and oxygen. With me so far. Oxygen has two distinct isotopes, oxygen-16 and a heavier oxygen-18. Water molecules containing light oxygen evaporate slightly more readily than water molecules containing a heavy oxygen atom. At the same time, water vapor molecules containing the heavy variety of oxygen condense more readily, so they get rained out first. Whether or not water has more oxygen-16 relative to oxygen-18 is temperature dependent, so the concentration of oxygen-18 in precipitation decreases with temperature. The measure of the ratio between oxygen-16 and oxygen-18 is known as delta O18. Rocks near the surface acquire hydrogen and oxygen isotope signatures from rainwater, but if there's an intrusion of a hot magmatic body into these rocks, then it initiates groundwater convection by heating groundwater, which cracks wall rocks and allows isotopic exchanges between groundwater and wall rocks. As the intrusion crystallizes and cools,
which is why you have to be careful with rocks near volcanoes and stuff, because they can, if you heat them, they can explode. Like sometimes people will put certain rocks, they'll put them over on heat, to either help cook something or to, as a massage tool or something, but you have to be really careful with volcanic rocks, because if you heat them too fast, they can explode.
The groundwater system collapses on the intrusion and alters the minerals of the intrusion itself. Over time, magmas gain an isotopic signature based on this process occurring over and over and over again. Zircon crystals retain their isotopic signatures despite episodes of remelting, so we can take oxygen isotope ratios in quartz and zircon and then use them to date the crystals based on oxygen isotope ratios, as well as track transient changes in the magmatic system, like fresh injections of magma from the mantle plume. If the zircon crystals have distinct oxygen isotope ratios, it means that they formed from isotopically distinct magma batches that were generated by the recycling of previously erupted material. Studies of the zircon crystals in Yellowstone reveal that they're between 0.8 and 2.1 million years old, and they are isotopically distinct from one another. When combined with the fact that the rocks they are contained in erupted less than 500,000 years ago, and the fact zircon analysis across the last three calderas shows a decrease in delta oxygen-18 in magmas, and then a gradual recovery towards normal delta oxygen-18 compositions, with the overall trend being a general decrease in delta oxygen-18 values across each caldera's life cycle. This overall decline and gradual recovery points to the recycling and remelting of previously erupted material. Taken together, it suggests that current Yellowstone volcanism is a combination of new magma production and the recycling of already erupted material, which includes lava and tuff. So Yellowstone recycles material. So what? A more powerful hotspot would be continually injecting magmas from deep in the mantle.
It would continue. It would be constantly pushing its way up, and it would always be more new stuff as opposed to old stuff that's just been remelted and remelt. Yellowstone is
recycling material. It suggests that the future melting potential of the crust is getting exhausted, which implies a decline in major volcanic activity in the caldera. Yellowstone looks like, Yellowstone because of a combination of its explosive history and landforms created by subsequent viscous rhyolite flows. But at Henry's Fork caldera just down the road, it's quite flat. And the reason it's flat is because the caldera got filled in with basaltic magma and was eroded with time. Henry's Fork caldera had a similar magmatic system to Yellowstone. However, once this upper crustal magma cooled and solidified, basalt magmas could penetrate the upper crust and erupt. These basalts, similar to the ones that erupt in Hawaii, are less viscous than rhyolites, so they fill in topographic lows. So Yellowstone could have another super eruption, or the mantle system feeding Yellowstone's present-day volcanism could wind down, the caldera system could die out, and it will just get filled in with boring basaltic lava like at Henry's Fork caldera. Right, so what I'm hearing from all this is that Yellowstone could explode and wipe out all civilization. There have been larger eruptions than Yellowstone in human history, which did not end all civilization, or even the human species. The Toba eruption, 74,000 years ago, ejected 5,300 cubic kilometers of dense rock equivalent material, and may or may not, likely not, have caused a human bottleneck. But an eruption more than double the size of Yellowstone's last eruption did not kill us off. Also, they didn't have the benefit of technology back then. The ashfall wouldn't necessarily be cataclysmic from a Yellowstone super eruption either. The problem with figuring out how far ash from past eruptions would spread is that ash deposits are eroded and rapidly redistributed by rain and rivers and wind, so very thin deposits far away from the volcanic source are not preserved in the geological record. And this lack of reliable data leaves the door open for liars to write volcano fanfiction on TikTok, like these guys.
First off, as soon as it erupted, tens of millions of people within 1,000 miles of the eruption would instantly die.
My source is that I made it the fuck up.
A super eruption would produce a lot of ash, but it wouldn't be a doomsday scenario. Depending on when Yellowstone erupted, even a month-long eruption wouldn't necessarily cover the whole US, and even if it—
I mean, I'd still be in trouble. I would be in trouble by April. No, it would get me in January. It'd get me in April. I'd be back again in October, but July I'd be okay. In July I'd be fine.
the East Coast would maybe get a millimeter or two of ashfall, less for a week and 3 days. And if the eruption didn't make an umbrella plume, even less of the US would be covered in ash. It's worth stressing any of these scenarios would be bad. A few millimeters of ash can reduce traction on roads and runways, it can short out electrical transformers and cause respiratory problems. A few centimeters can cripple agricultural production. Salt Lake City would be buried under thousands of tons of architectural improvements. But even the worst case scenarios wouldn't be world-ending. One thing a eruption would do is alter the climate.
I mean, it would be terrible, but like not in a, apocalyptic way. All right, but it is interesting. Like I heard climate alteration would be interesting.
When Pinatubo, a stratovolcano in the Philippines, erupted in 1991, it had a VEI of 6 and injected nearly 20 million tons of sulfur into the stratosphere.
Wow.
Dispersal of this gas cloud around the world caused global temperatures to drop temporarily by about 0.5 degrees, or a degree Fahrenheit in American units. The 1991 eruption of Pinatubo was about 100 times smaller than Yellowstone's largest known eruption, so it stands to reason that a Yellowstone super eruption would have a bigger impact on the climate. Foraminifera are shell-based organisms whose shells contain temperature-dependent oxygen isotopes that reveal the sea surface temperatures in which they lived. Based on analysis of foraminifera in the Santa Barbara Basin, the oxygen isotopes in their shells suggested that the 631,000-year-ago super eruption cooled the oceans by 3 degrees Celsius. It's hard to simulate the impact of a volcanic super eruption because of knock-on effects an eruption can have on the ocean, atmosphere, chemistry, land surface, vegetation, cryosphere, carbon cycle, etc., etc.
So much,
One 2012 study attempted to resolve the impacts of a super eruption using an integrated Earth system model. Mean global changes are a 3.5 to 4.5 degree cooling over 2 years, followed by a quick recovery by year 5, and a slower recovery to normal by year 20. There'd be a mean 7 degree cooling over land, and a 2 degree cooling over the oceans. The cooling would also encourage sea ice growth and make the planet more reflective, which would reduce the amount of energy received at the surface.
That could be better.
So Earth system modeling largely agrees with past eruption climate reconstructions. A Yellowstone-sized super eruption could cool global temperatures by a few degrees for a few years before they recover. The eruption would also change surface wind patterns and ocean circulation patterns, as well as reduce land vegetation cover. Now, this wouldn't be great. The famous year without summer occurred in 1815 after the Tambora eruption caused a global decline in temperatures of about 0.4 to 0.7 degrees. It resulted in mass famines across Asia and Western Europe.
That would be bad. I was thinking more about like climate change in general and global warming being a problem and like the ice caps being destroyed slowly. So I was thinking a cooling in general would be good. But I also, it kind of suck. We've got to because the farmlands would be in trouble. We would be boned a little bit.
Political unrest. It more or less erased 7 years of population growth in Vermont. It inspired Frankenstein, but as a species, we survived it. To quote from Timrick's paper modeling the climate impacts of the Toba super eruption, temperature changes might have created thermal discomfort for prehistoric humans, but they were unlikely to have been a challenge. And even entertaining this idea misses the far larger point that the evidence points to a caldera system that is winding down, and the most likely volcanic scenario at Yellowstone would be a simple lava flow with impacts contained to Yellowstone National Park. Like, this isn't a joke. Yellowstone isn't even in the top 10 for the most dangerous volcanoes in the United States. It's not
Dang.
even in the top 20.
Wow.
It's ranked 21st on the USGS's Volcano Threat Assessment list. I'm 99.9% sure that 21st century society, or even way beyond, isn't going to experience an extinction-level Yellowstone super eruption. If it even erupts again, Yellowstone isn't going to explode and end civilization.
Bummer.
Hey,
Me
it's
too.
okay. We can find another way to destroy civilization.
Sure we
right,
will.
guys? Oh, yeah,
So-
yeah. Don't worry about it. Yeah, don't worry a little head.
All the politicians. All the politicians who are helping with that. Damn straight they will. Alright, so some fun
Jokes. So
patrons.
if there was something in here that you found funny, chances are monster. Special thanks to my patrons whose names and doodles are appearing on screen now, and an extra special thanks to the patron who drew the Wham-oop as well. It's an amazing drawing. Patrons got to see an earlier rough cut version of this video and gave me a lot of notes to make it a lot better, and they got to see it early as well, which is pretty neato. Also, patrons suggested ideas for jokes, so
Good for
if there
them.
was something in here that you found funny, chances are I stole it. If you want to help with these things, and I'm not sure why you would, but if you
I
made it
liked
this
the
far, you must
debunk
implicitly
beds.
think there is some value in this, then consider
guy
subscribing
who
or maybe
pays money
heading
to
over to the
spike the
Patreon
YouTube
or check out the
algorithm.
other stuff that I've made.
I like you people
Or you
who
can
do
do
that.
none of those things. It's your life. I'm not your boss. The best boss in life is you. Don't forget that. Speaking of funny stuff, credit to Maxor. I don't know if I'm pronouncing
Maxor!
it right. Credit to him for the Senator Armstrong bit. I laughed my whole off at an incorrect summary
That was a good one. That was a good video. An incorrect summary of Metal Gear Rising.
of Metal Gear Rising. This was fun to make. There is a lot of Yellowstone misinformation on YouTube, like a lot
Maxor
of it.
video is good too.
Except
I
for
did reactions
SciShow.
to it.
SciShow were the one channel I came across who actually made a calm down about Yellowstone video. God bless them, and God bless you, Hank Green. Actually, there are
Yay!
lots of bits of misinformation I didn't even touch on in this. Like the 10-degree cooling figure that you can see floating around. That comes from a 2005 paper written by Jones et al., which uses a climate model called an atmosphere and ocean general circulation model. I didn't use that paper because it was a general model rather than a volcano-specific one, and it modeled a low-latitude eruption, so a volcano on the equator, but Yellowstone
different.
is a mid-latitude volcano, so it would have different impacts on the climate system. Also,
Cool.
like modeling for an eruption 100 times Pinatubo's size, which is what we think the size of Yellowstone's most recent super eruption was, and what we think might have been the size of the Toba super eruption. There's a lot of sort of disagreement on that. It might have actually been a factor of 10 lower than that.
Okay, well.
The range of temperature changes seems to be about 3 and 5 degrees. That's not to say the 10-degree paper is wrong, but as far as I can tell, the 10-degree figure is chosen
just
to kind of overstate
general.
the case of harm.
Okay.
It's a little bit of an outlier in terms of the wider research on modeling the climatic impacts of a super eruption.
Cool.
God, I could talk about volcanoes for ages.
Volcanoes are cool.
I've rambled enough. I have to be in a different country now because of circumstances, so I will love you and leave you.
Bye. All right. Okay, that was really cool, and I really liked the sort of post credits explanations that were going on too. That was interesting. When I saw the I made it the fuck up thing, I was thinking I couldn't remember specifically what it was from. I remembered metal and I remembered snake. I'm like, that's what I remember from it. I was like, but I remembered what it was from ish. I did like that video though. I have done a reaction to Maxor's incorrect summary of Metal Gear. And I feel like I've done reactions to all of Maxor's incorrect summaries videos. So go check those out on Chicago Reacts. Give Soup Emporium a big ol' thumbs up. That was a great video. I mean, I'm assuming that he's correct about everything. And I'm like, oh, this was so much fun. Okay. I don't do the science videos super often because they don't really perform well. But I really did enjoy it. And I always enjoy them. Anyway, thank you so much for watching this. I hope you did. Go check out some of our other stuff. Don't forget to like and subscribe to this channel if you want to see more stuff like this. And I will see you in the next one.